Hi dear students. So in the last section we have discussed the example 3.3 and 4. Now we are going to discuss about the example which is dealing with the free fall. Free fall is actually, suppose if you are dropping one object from a height, if it is not connected with any of the bodies or any string or something, and if you are allowing it to fall freely downwards, such motions are known as the free fall. In another words, we can say that an object released near the surface of the earth is accelerated downwards or towards the earth or the surface of the earth. Actually, it is due to the gravity. You know that the gravitational force of earth which attract all the things towards it. Okay, so this free fall is due to the gravitational attraction force of the earth. And the acceleration, actually we have seen that the object, if you are releasing from a height, then it will be accelerated towards the earth. So the acceleration value is known as the acceleration due to gravity, and its magnitude is 9.8 meter per second meter per second square, and it is represented by g. It is the acceleration due to gravity, so the acceleration is represented by g. And one more thing, we will not be considering the air resistance. Actually, the object which is passing through the atmosphere or the air, so there will be a resistance to its motion due to, or a frictional force is there due to the air particles, but we are neglecting it. Then only we can consider that one as a free fall. Okay. So if the height through which the object falls is small compared to the Earth's radius, g can be taken to be a constant, and its value is 9.8 meter per second square. That means the height should be, if the height is lesser than the radius, then the acceleration value will be 9.8 meter second raised to minus 2. Okay. Now, so we can say the free fall is actually a motion with a uniform acceleration, and the acceleration value, it is g. And one more thing, the acceleration which is acting downwards, isn't it? So as we know, the positive x direction is towards the right side, negative x direction towards left side. As well, the positive y direction is upward and negative y direction is downwards. As the g is acting downwards, it is acting in the negative y direction, so we have to take the g value as a negative 1. Okay. For representing the direction also, you have to take the g value as a minus value, that is minus g, then the value will be minus 9.8 meter per second square. So the direction of the motion is also in the negative direction. The direction of acceleration is also negative. direction. Now let us come. So the acceleration minus g will be is equal to minus 9.8 meter per second square. And you know that the object is released from rest. We were holding it, and at some point of time we are releasing it. So the initial velocity, okay, so at rest the position will be is equal to 0. Initial position y is equal, we will take that one as a 0, and v0, the initial velocity, will also be 0. Then the equation of the motion, so we have to consider these things, that is acceleration is minus 9.8 meter second square, y is equal to 0, and initial velocity v0 is equal to 0. So as we are considering these conditions in the kinematic equation, the equations will change as follows. V is equal to v0 minus at, sorry, v0 plus at is equal, isn't it? So here v0 is v0, then acceleration plus at, acceleration is equal to minus g acceleration is equal to, wait, v0 is equal to 0, then acceleration a is equal to minus g, and initial position y0 is equal to 0. Then the displacement will be, if the final position, if it is y, then displacement will be y minus y0, that is y minus 0, which will be is equal to y. Okay, now substituting the value, v is equal to v0 plus at, where v0 is equal to 0, we have substituted, and plus at, where a is equal to minus g, so minus gt. Now y is equal to v0 plus v0t plus half at square, where v0 is 0, so v0 into t will be is equal to 0 minus or plus half at square, where a is equal to minus g, so minus half gt square will be there. And we are substituting the value of g in that equation, and you are obtaining a particular equation in terms of t only. The last one, v square is equal to v0 square plus 2as, where s is the displacement. Here the displacement it is y0, sorry, y minus y0, that is y minus 0, so which will be is equal to y. Substituting the acceleration value as minus g, you will get the equation v square is equal to minus 2gy. Substituting the g is equal to 9.8, you will get the v square is equal to minus 19.6 y meter square second raised to minus 2. Actually these equations are, if you are going through this equation, and if you are by hearting this equation, this will be helpful in the competitive examinations. Okay, the final equation, then you don't want to derive the equation, just you can put the equation and find out the answers. So just go through this one, and now come to the graphical representations. For a free fall or for a body which is undergoing the free fall, the acceleration time graph, the velocity time graph, and the position time graph. This one is also can be asked in the MCQ questions. So acceleration is always a constant. This is 9.8 meter second square, that is minus 9.8 meter second square. You know that the value it is minus, so it is represented in the negative y-axis. Okay, origin is over here. This is the positive x-axis. This is the negative y-axis. As well for free fall, the velocity and position, all those values are represented in the negative y-axis because all those values are negative only. Downward motion and negative acceleration. Okay. So the acceleration, if you're seeing that acceleration value, that is minus 9.8 meter per second square. If you are going for the first second, it is same. Second also same. Then third, fourth. Likewise, if you are going, you will get a straight, constant line. Now, come to the velocity time graph. The velocity, actually this is a uniform motion, that is the velocity is increasing in a equal interval with the equal interval of time. Okay, for the first second it is 10, then going for the second that is 20. That means for the 1 second there is a change of 10 meter per second velocity is happen, isn't it? If you are taking the difference between some adjacent seconds, that means 3 and 2, that means 30 minus 20, which will be is equal to 10 meter per second. So it is a uniformly or the velocity is equal in equal intervals of time. Now come to the position graph. Position time graph. You can see that initially the velocity was less. So the first second displacement is happening less only, and afterwards it is increasing. So as the time changes, you can see for the first second the displacement happened is near about 10 meter only, but for the second it is near about 30. Third second it is getting near to 50, and fourth second it is near about 80. So as the time increases, the position, the change in position is increasing because it is uniformly as a uniform motion, that is for equal interval of time the velocity is increasing equally, and you are getting a parabolic graph. Okay, a curved parabolic graph you are obtaining. So remember these graphs. Okay, it can be asked in the MCQs as well, 1 mark question also it can be asked. Okay, now come to the stopping distance of a vehicle. So for that you will be using the equation, the third equation, that is v square is equal to v0 square plus 2 ax. Let the distance travelled by the vehicle before it stops be ds. Okay, so a vehicle is moving with some velocity. Okay, so now at a point it applies the brake. So after applying that brake, how far this vehicle moved, that is the ds value. Okay, so and here we know that at this point the velocity, that is the final velocity v, will be is equal to 0 because it is completely stopped. Okay, at the point, let's name this point as a. At point a, the v will be is equal to 0, that is the final velocity will be 0. There is a value for v0, that is the initial velocity, the velocity with which that body was or the car was moving, that is the v0. So how will you find out the ds? So here the v square will be 0. So you can see that if you are taking the v0 square on the left hand side, the 2ax will be is equal to minus v0 square, where this x is actually the ds. Okay, that is the ds. So minus v0 square divided by 2a will give you the ds value, that is the stopping distance. Okay, one second. So stopping distance ds is equal to v0 square minus v0 square divided by 2a. So suppose the acceleration, if it is constant, and if you have applied the brake at 2v0, that if in the initial case if you are applying the brake at 40 meter per second, in the second case if you are applying the brake at 80 meter per second, that is the according to the first case you have doubled the velocity. Okay, so that is 2v0 will be there. Then the stopping distance will become the 4 times more than the initial case. It means 2v0 means 2v0 the whole square will be there, that will be is equal to 4v0 square by 2a. Okay, where v0 square by 2a is the initial condition stopping distance, and after you double the velocity, the stopping distance become 4 times more than the initial case. Okay, the stopping distance is proportional to the square of the initial velocity. Doubling the initial velocity increases the stopping distance by a factor of 4. For the same deceleration means the opposite of acceleration. Here the speed is reducing, no? So this term, this acceleration term will be known as, that means a negative which acceleration is decreasing, or the decreasing acceleration, that is known as the deceleration. Okay, so I think these much things are clear. So 2 examples questions we have we did not discuss that one. So one is that Galileo's one, and the last one the reflex time or reaction time. So just to go through that 2 examples, actually both are easy only and direct application of that equations, kinematic equations. Just to try that out as well, you just write the first calculus, that derivation of the kinematic equation using the calculus method, that you should write in your notebook, and also the free fall and the stopping distance, these two also should be you should write all these two ones also in your notebook. Okay, thank you.